I wish to introduce Dr. Kamar Abbas of Poznan University of Technology. We're going today talk about supercapacitors. Would you like to give us a little bit of a summary of what you're doing?
So we are developing mainly on carbon capacitors because they are very famous in the market. Activated carbon is a high surface area material which is used in commercially available supercapacitors. So this is our electrode material, and we also work on low-cost aqueous electrolytes, which can be made by solutions of lithium sulfate or sodium sulfate. And by this way, we develop carbon symmetric capacitors. And recently, what we changed in this aqueous electrolyte is to introduce redox species. And so what it does is that at one electrode it makes the potential constant, and one of the electrode is mainly operating as a double layer capacitor. So one electrode is a battery type, and the other one is a capacitor type electrode. So by the formula of capacitance calculation, we can make the capacitance almost double compared to the symmetric capacitors. And this is possible in aqueous electrolyte to develop a hybrid capacitor. Like a hybrid capacitor which, for example, JME is making, or UNESCO, these companies are making.
Yes, JR, yes.
But of course we are using aqueous electrolytes, so the potential window is small. These are some of the disadvantages.
So with supercapacitors and pseudocapacitors and asymmetric double layer capacitors, there has been concern about toxicity, hasn't there? There's been acetonitrile which forms arsenic in your body and also creates HCN if you overheat it. So an aspect of what you're doing is to escape from toxic issues. I mean, with pseudocapacitors, ruthenium is a concern, and to some extent, vanadium salts might be a concern. And your products would appear to be relatively non-toxic. Is that right?
It is true. Acetonitrile has been a concern, and some of the countries like Japan has made some legislations to even stop its imports in the country. Yes. So it makes actually our case even stronger, that the aqueous electrolytes, you can reach up to a voltage of 1.6, 1.7 volt. Of course, under the working conditions, I mean. And with the organic electrolyte using acetonitrile, you can reach to 2.7, 2.8 volts. We lose on the point of view of voltage, but then if we introduce redox species in this electrolyte, we can enhance on the point of view of capacitance. So our energy, which is a product of capacitance and the square of the voltage, we can try to reach to the performance of organic electrolyte-based supercapacitors.
So I know people were skeptical of the Japanese trying to avoid acetonitrile and going to lower voltages and so on, but Nippon Chemicon has been very successful selling to Honda and Mazda and so on, quite big supercapacitors. I think that's propylene carbonate. You're not using propylene carbonate, but you're in that world, really. Yes.
Propylene carbonate is a replacement for acetonitrile, but it also has some of the disadvantages related with the conductivity. As a solvent, it is good, but then there are questions of conductivity, and conductivity is determining the capacitance. Yes. But surely there are replacements for acetonitrile also in organic medium.
And when you say you go to some redox contribution, in other words, you're going to something that is all these horrible words, aren't they? Supercapacitor. It's a mixture of a battery and a supercapacitor. You're doing that, but when you say you've got double the energy density, what sort of figure would that be? 15?
So normally in commercial supercapacitors, it depends how your method of calculation is, and which items or components you take into account. but normally it is something like 15 watt-hour per kilogram, which we can...
15.
15.
But isn't that what the commercial people like JR Energy and UNESCO and the others are achieving commercially? You're not talking about in research something better, are you? Or?
Definitely, the advantage is that we can work more on these systems.
Yeah.
The assembling of the cell
Yeah.
is itself very easy, and you don't spend a lot of money. You don't have to work in the glove box.
Yeah.
You are working on
Yeah.
open scale. You can improve. And this is what I would like to mention. The Poznan Energy used the idea which was developed by Francois and Beta from Poznan.
Yes. Yeah.
And they used this the overpotential on the negative electrode to gain high voltages. And Poznan Energy developed this so-called sodium-ion battery, which can reach to 1.8 volt.
Yes.
So this is how they reach, is by taking the advantage of overpotential for the water reduction, which is not available in traditional aqueous electrolytes like potassium hydroxide or sulfuric acid. No. You will know that the NEC or Japanese company were developing some of supercapacitors with sulfuric acid.
Yes.
So by using this overpotential on the negative electrode in neutral aqueous electrolyte, which have neutral pH, we can enhance the voltage from 0.7 or 0.8 volt to 1.6, 1.7 volt.
Yes, yes. We have just done a report on toxicants, poisonous materials in the electronics and electrical engineering and alternatives. So one part is concerned with the supercapacitors and the alternatives that you're talking about. But if I understand you correctly, you're really offering potentially quite a number of advantages, because these could be lower cost materials, they could be lower cost manufacturing processes without tremendous problems of getting rid of water and everything, exact opposite. And they could be products that, as you develop them, will get higher energy density.
Yes, it is true. Also, on the point of view of electrode material, I would like to mention that people are using graphene, nanotubes, such kind of exotic electrode materials.
Organics now, isn't
it?
Yes.
It is a fashion, but activated carbon has been, and I think it will remain for quite a while, a choice electrode material for such devices.
Yes. Well, there's some sort of mixtures, aren't there? The carbon from carbide produces a bit of everything, I think. So
yes.
You've got people like Skeleton Technologies here have quite nice supercapacitors that I believe are carbon from carbide. Yes.
It is.
Yes, but it's not fully a new carbon allotrope, really. I think they have some graphene in them, but that's what
it
comes
is.
From that process.
I was in Jena last year. There was a supercapacitor conference, and they call it a curved graphene.
Yes.
So it is a name which they gave it to.
Yeah, they've got a good product. It's an interesting situation in Europe where we have some of the most outstanding research. Whether it's Skeleton Technologies, it's your work in
Skeleton Technology doing a great job.
Kiev University in Ukraine, and setting records all the time. But we don't have any big supercapacitor companies yet, but hopefully we'll get some, because it's certainly at IDTechEx we think the market, having gone sideways rather for a few years because the Chinese stopped the subsidies for the hybrid buses, which were the biggest application.
Yeah.
They've now turned on those subsidies again, oddly enough, very unpredictable. But for that and for lots of other reasons, there are many other applications that are opening up. We think that these could be structural components, the body of a car and all that. We've got work here at the event being reported on structural supercapacitors. Do you have any dreams about applications? Do you see these things in large area applications, or very small, very big? I mean, what's the twinkle in your eye?
I think that in the future, these devices, especially low cost, they are good for stationary application.
Yep.
also for the applications in tram lines, in buses, where you can, especially in tram lines, where you can use energy during regenerative braking and store it in the
by the side, or it might be on the tram. Yes.
And you can use it for the acceleration at the initial, rather than using the engine for this purpose. Recently, we were in contact with a company in Poznan. Of course, when you start working and then you start to see how the market is. Market was not great in Poland at the beginning, but now there are some very good companies.
Yes.
Solaris is a very good company.
Yes, I visited them. Very impressive company.
Yes. And they are interested in supercapacitors, and they make tram lines. They are developing buses, and now they want to work with the hybrid buses. And they want to use these products. But our collaboration is at the initial stage, and but there is optimism. So let's see.
That's good. Well, thank you very much. Wonderful to hear your story, and we'll keep track of you in future. Thank you.